Hi, welcome to Harisystems. In this session today we will learn Rasberry PI distance sensor using with the programming of Python language. The sensor newly introducing here ultrasonic sensor HC-SR04, that particular module name. We are working on that particular sensor. Now see the step by step. I will explain you completely with the Rasberry PI model. Now see here, introduction. For many outdoor projects, a distance measurement is necessary or advantageous. It will gives to identifying and measuring that particular the distance of the things which is nearby to the sensor and which are going in front of the sensor, that particular equipment and all. It can be very much useful. These small modules are available, can measure the distance up to 4-5 meters by ultrasound and are surprisingly accurate details it will gives to the system. This tutorial shows the connection and control the sensor using Rasberry PI module. About HC-SR04 sensor, distance sensor measures distance based on emitting a sound burst and timing how long it takes to retrieve the echo back. Using the known constant, that is the speed of sound, we can mathematically determine the distance of the object in front of the sensor by simply measuring the way and the distance of the particular object in it's going or it's moving around the in front of the sensor. And we can also simply measure how much time passed while the sound waves were created. Hit the object in front of the sensor, back bounced and came back to the sensor, what it will be taken time, and by using the ultrasonic waves and sounds we can estimate it. The requirements of the hardware to complete this module, the project and activity. The hardware requirements are HC-SR04 module, ultrasonic sensor. It will be available where the electronics devices are available in the major education projects and all. This particular module also available. And Rasberry PI 2 or 3 plus, now it is the latest up to which we are preparing for this video time. 3 plus is the latest, which can be used to write a functionality. We are used 3 plus device. And resistors 330 ohms and 470 ohms, and jumper wires which is required accurately. I will show you the pictorial representation of the connectivity, the diagram, where you can find out how many wires and all it's required. Based on that you will collect it. Now connecting and the wiring of what we are like it's an assembling the modules, how to make a functionality. There are 4 pins of the ultrasound module, that particular module. See earlier screen, these are the 4 module that pins are available in this particular module, that VCC, triag and echo and one more. That is the pin of GND. Now see here, VCC pin 2, VCC to pin 2 and GND to pin 6 and TRIG to pin 12, that is the GPIO pin 18 we need to connect to that particular sensor module. Connected to 330 ohms resistor to echo. On its end you connect it to pin 18 of GPIO 24th pin, the GPIO board pin. And though a 470 ohms resistor, you connect it also to pin 6, that is the ground. GND indicates. It's done because of the GPIO pins only tolerate maximal 3.3 volts. The connection to GND is to have obvious signals on GPIO 24. why we used and why we are used these resistors, and why we are connected on particular ports in GPIO board of the Raspberry PI module, and to connecting to invoking this particular device here. This is the ideology of our program. Now see here, if no pulse is sent, the signal is 0 through the connect with the GND, else it is 1. If there would be a no connection to GND, the input would be undefined if no signal is sent, randomly 0 or 1. So ambiguous. Either 0 or 1, true or false, can also be treated. In writing of the program, you can also write either 0 or 1, or you need to choose either it's in a true or false manner. See, this is the circuit diagram. Here is the structure as the circuit diagram showing the pictorial representation. This is the breadboard where it's going to be connecting these pins of module of sensor device. R1 resistor 330, it should be connected like this, and this is the R2 resistor 470 ohms, it is connecting to from here to here. Identify this. These are the cables you need to connect to with this Raspberry PI board model. It's showing the picture with the GPIO pin structure of Raspberry PI. Accordingly, you can connect. You have to take it with this proper diagram wise. You need to connect manually. Now we will straight away go to Python script for controlling the sensor. How we need to receiving accurate information from the sensor to either storing, or first of all in this program we will see how we are getting the program output. What is the device if the sensor is occurring something that in front of the images, or something that objects are moving around the sensor facing. Now how it is how the based on the distance it's representing that values mathematically into the program. If we received anything from that particular sensor, we can also know that how to store and how to utilize that value in a future manner. We'll see all about later. In this program we will see how. See, now here I'll tell you. First of all, the Python GPIO library should be installed in Raspberry Pi module particularly. And to use this module, to create a new script, open the Raspberry Pi, the user, the prompts it will indicates, and nano or vi, which is you comfortable, that editor you can use it. We are using nano, hence I am placing that name of the file is distance.py. Now the py I am opening this, and hash indicates it's in a comment line. I am specifically writing that these are the libraries I am invoking into my project. Now here see, import rpi.gpio as GPIO I am declaring, and import another module, that is the library, it's a time. And GPIO mode, board and BCM, there is the two modes are available. I am taking set mode as a BCM. Set GPIO pins, what are the pins? It is triggering and echoing, which I am connecting to that particular board. GPIO pins to the sensor I am indicating here, that is a trigger is an 18 and echo is an 24. And the directions of the input output, which pin is the input and which pin is output, it's showing. Now I am setting that GPIO setup, GPIO underscore trigger, that is an output, and GPIO underscore echo, that is a GPIO input I am declaring over here. Now define distance. How we need to take care about the distance and all. For that, what we need to do? See, the distance, defining a function distance, the trigger first I am defining as in a high picture, and set trigger after 0.01 ms to low. Time dot sleep 0.00001, 4 zeros after decimal, there is a 4 zeros 1, and GPIO dot output of GPIO underscore trigger, that is an I am taking as a false, that is a 0, and that is a low latency ultra distance if it is. Now the start time that equal to time dot time, and stop time time dot time I am declaring over here. For the taking the start time and stop time, we need to estimate for the distance. Now see, save start time. While GPIO pin I am creating in a while loop here. GPIO dot input echo if equal to 0, start the time, and save time of arrival. While again I am creating the while loop for arrival of the object. GPIO dot input of GPIO underscore echo if equal to 1, and that equal to time dot time. Now time differences between start and arrival. Time elapsed stop time minus time elapsed, that is stop time minus start time, and multiply with the sonic speed, that is indicates 34300 cm/s, and divided by 2, because the there and back, the ultrasound it will comes from the object and it will be back. Hence we need to take in a distance that equal to time elapsed into, that is a cross mark, 34300/2 by 2. Return the distance. What is the distance it's getting? That is the distance only that object is, that particular distance that object is occurred while sensor is saying that. Return the distance. Return the distance in the function. How it will returns the value? It will be returns like by using this return parameter. If name underscore name, if you are know about the Python language, you will be know these are the functions and all that equal to the declaration of the calling the main function. Try while true, distance equal to distance. What is the distance it's getting? It will be invoked to the distance place here. The assignment dist, it will be assigned over here. Now print distance of percentile 1f c centimeters of percentile of dist. It will be print the distance of the object, how much distance it is. Time dot sleep, and it will be waiting for 1 millisecond to wait for another object if may occurs. It will see vice versa, and now it will continuously running, keep on running. That object is coming, it will be prints the display. If object is nothing, there is no, it will wait and it will try to read again and again the objects. Once if you are hit by Control plus C, then only it will terminate the running of that particular program and it will exit. See now, except keyboard interrupt, print stopped by user. If you are hit the Control plus C, it will indicate that message stopped by user. And GPIO pins dot there is an already readed data, something it may occurs while using the electronics. Now we need to clear the GPIO dot clean up everything, that by using the default function, that you need to write this line and save and quit from that particular editor. Here I am using VI editor, hence there is a command :WQ is the save and exit. Now we need to run the following by using this following command on Raspberry PI sudo python space distance.py. The distance.py, which file you are created, the name of the file with the extension of py indicates Python language. You need to run the following command to execute. Now you will measured until the script is cancelled by pressing Ctrl C. It will runs and it will measure the objects which is in front of the sensor. If nothing is there, you try to put something in front of sensor. That's it for measuring distance using Raspberry PI. With the sensor module, you can also use many outdoor fields. Something is occurring with this particular device or someone is going to do something. Then that type of data you will collect by using this sensor. If it is a large based and large distances, it's not, if you are we said that 4 to 5 meters only. If you need large distances and all, the simple thing that is you need to buy in a large distance catching sensors and attach to this particular Raspberry PI device only. Rest of the program, everything is same to same. And the Raspberry PI also very low cost, it's available in the market, and also students can also use their small mini project and major project by using electronics guys, especially they can avail of this project and do them. And similarly, the computer science background people also, they also avail with this programming language in the Python. They need to implement by using this concept, as well as many of the concepts are available in the Raspberry Pi. This is the Raspberry Pi especially inventing for IoT devices, Internet of Things. That's all. Happy learning. Thank you for watching this session. Please subscribe, like, share and comment any of your views regarding this. Thank you.